Is the universe real, or are we merely illusions? This question has confounded philosophers and modern scientists since the dawn of human knowledge. There have been numerous interpretations that cast doubt on the reality of our universe over time. Some believe we are actors in a pre-written plot, such as a play or a movie, while others believe we are in a game like SimCity. There's also the philosophical issue to consider. What precisely is reality? Three physicists contend that reality may be distinct from the universe we inhabit. The concept of reality and our universe, as we have long recognized it, has been erased by this year's Nobel Prize winners John Clauser, Alan Aspect, and Anton Zeilinger. What is reality, and is the world we inhabit real or unreal? The size of our universe can be so overwhelming that you may start to doubt whether anything so enormous exists. By merely capturing photons, the James Webb Space Telescope can peek into different eras of our cosmos. Much of what it reveals does indeed seem fantastical. Furthermore, why haven't yet discovered life elsewhere if the cosmos is so vast and there are potentially billions of planets out there? The repercussions of the empirical breach of Bell's inequality have been a topic of discussion amongst physicists and philosophers for several years. According to physicists, the special theory of relativity may not be correct because the world is non-local, and the empirical violation of Bell's inequality shows that. Philosophers propose that this conflict can be avoided by giving up a realistic interpretation of quantum mechanics. But what does the phrase, "the world is non-local" mean? In physics terms, being real means that objects have definite properties even when they are not observed. A tree can still make a sound if it falls in the woods, even though no one is there to hear it. A strawberry can still be red even when no one looks at it. Albert Einstein once famously told his friend, "Do you really believe the moon is not there when you are not looking at it?" Being local means objects can only be influenced by their surroundings, and no influence can travel faster than the speed of light. A supernova exploding 100 billion light years away can't scare a bird into flight. Still, the roar of a tiger nearby can. However, there is a problem with these two concepts. Studies in quantum physics have led to the conclusion that both of these phenomena cannot be true. There is a third concept in classical physics called causality, which means that things don't happen randomly. They follow the chain of other things happening before them. A person walking in the park will not fall all of a sudden. There has to be a reason for their tumble, such as tripping, being pushed by someone, or perhaps slipping on a banana peel. For event B to occur, event A needs to happen. However, quantum functions have implied that one of these three concepts is not true. But, and this is the tricky part, we have no idea which one is false. It's the mystery of all space and time, and the answer lies in quantum entanglement. The most basic explanation for quantum entanglement is that aspects of one particle is an entangled pair depend on aspects of the other particle regardless of how far apart they are and what lies between them. Socks are the most obvious analogy for such a pair. A left sock is always paired with the right one. Otherwise, something won't feel right. These subatomic particles could be electrons, photons, or any other similar particles. An aspect refers to the state it is in, such as whether it is spinning in one direction or another. The weird thing about quantum entanglement is that measuring a trait of one particle in an entangled pair would also reveal some information about the other particle immediately. Even if millions of light years of distance separated them, even if they were at opposite edges of the universe. One particle can reveal something about the other. But how? Albert Einstein famously called this phenomenon spooky action at a distance, because this strange connection between two particles breaks a fundamental law of physics. In a complete theory, there is an element corresponding to each element of reality. A sufficient condition for the reality of a physical quantity is the possibility of predicting it with certainty without disturbing the system. In 1935, Einstein and two other well-known scientists, Podolsky and Rosen, criticized quantum mechanics. They claimed that a particle predicting something about its entanglement partner over a long distance accurately every time is absurd. The odds of doing so even 200 times in a row would be 1 in 10 to the power of 60, which is a number greater than all of the atoms in our solar system. This suggests that the particles communicate with each other through some means that moves faster than the speed of light. Still, according to the laws of physics, nothing can travel faster than the speed of light. Surely the measured state of one particle cannot instantly determine the state of another particle at the far end of the universe. To many scientists, something was missing in these calculations. They theorized that some hidden variables determine the state of a particle before measurement, and this is where Irish physicist John Bell comes in. Bell created an equation known as Bell's inequality, which led to the experiments conducted by John Clauser, Alan Aspects, and Anton Zeilinger. The mystery of us and the rest of the universe being real hinges on the three concepts called locality, causality, and realism, and finding out which of them is an illusion. It is because although pairing two of these concepts makes sense, adding the third one without removing one of them from the mix breaks the wheel. There have been different interpretations of quantum physics that have tried to answer this question. According to David Bohm, a locality must be an illusion because there must be a predetermined script for the universe's functionality, which means something that is not local must be affecting the state of a particle. According to Copenhagen's interpretation, realism must be false because the universe is not exactly determined until it is observed. On the other hand, the many worlds theory claims that causality is an illusion since there must be an endless number of universes and that each possibility occurs simultaneously in different realms. Nobel laureates in physics conducted experiments in 2022 that definitively disproved the existence of hidden variables, a puzzling property that would dictate in advance the states of entangled particles. This indicates that local realism is invalid. Additionally, there is no issue with special relativity, which prohibits communication at speeds faster than the speed of light. It means that realism is an illusion, and that Copenhagen's interpretation is the most plausible scenario. However, that doesn't rule out David Bohm's theory either. These investigations performed by the three scientists had a small constraint. Since the experiments were carried out and the results were recorded locally, there is a good likelihood that the universe we are experiencing is a simulation until we are certain that the locality is real. A pre-written fate is awaiting all of us, and as Shakespeare once said, we are only acting out our parts written by someone else. Still, these scientists have proved that many world interpretations are not true and causality is real. Nothing happens without reason, and there is no alternate universe solely existing, just so your alternate self can make exactly the opposite decisions as you do. Hence, it is safe to say that the universe is not locally real. Still, it begs the question, does the universe's state depend on our observation? If there was no one to observe it, would the universe not exist? Are we humans really that important for existence, or does the universe exist only in our heads? And if so, what are we then? Can we also assert that things we hallucinate or imagine could be real if the observation is proof of existence? Although we are still far from learning the truth, the study carried out by these outstanding experts has moved us in that direction. That is our video for today. We hope you like it. So, do you think we are real or not? Share all of your thoughts with us in the comment section below. Well, that's all for now. This is Big Tech Media. See you again tomorrow. Keep in mind to like, share, and subscribe.